friends, welcome to our Mathematics Grade 9 program. Our topic for today is inequalities. It is the third video on inequalities. So you will recall that in the first video, you had learned about the different inequality signs and also how to represent linear inequalities on a number line. In the second video, you had learned how to solve linear inequalities. In today's video, you're going to learn about the set builder notation and how to find the solution of inequalities using the set builder notation. So let us start. What is the set builder notation? It is a mathematical notation for describing a set by listing its elements or by stating the properties that the elements must satisfy. Look at this example. This is a set builder notation. So how do I read this? You will recall that R is the set of real numbers. So X belongs to the set of real numbers. And this statement is read as the set of all real values of X such that X lies between 2 and 8, including 2. I repeat, this statement is read as the set of all real values of X such that X lies between 2 and 8, including 2. Now, let us look at the different set builder notations. In fact, we are going to look at 8 different cases. So the first case, the set of real numbers between A and B, but not including the values of A and B. So you will recall that on a number line, if I have a set of real numbers between A and B, but not including the values of A and B, this means that I'm going to have 2 unshaded circles at A and B. So this will be the representation on a number line. Now, using the set builder notation, I'm going to write it as X such that X lies between A and B. So this is how you write it. Case 2. The set of real numbers between A and B and including the values of A and B. So here the values of A and B will be included. So this means that we are going to have 2 shaded circles at A and B, as you can see on the number line. So the set builder notation would be X such that X lies between A and B, including A and B. Case 3. The set of real numbers between A and B, including A, but not including B. So here B is not included and A is included. So this means that I'm going to have a shaded circle at A and an unshaded circle at B. Now the set builder notation would be X such that X lies between A and B, including A. The fourth case, the set of real numbers between A and B, not including A, but including B. So here A is not included, but B is included. So I'm going to have an unshaded circle at A and a shaded circle at B. And in set builder notation, we're going to have this statement, X such that X lies between A and B, including B. Now the fifth case, the set of real numbers that are greater than A. So in set builder notation, it's going to be X such that X is greater than A. And I'm sure you will remember that on a number line, I will have an unshaded circle at A, and the arrow will point towards the right. Case 6. The set of real numbers that are greater than or equal to A. So here, in set builder notation, I'm going to have X such that X is greater than or equal to A. And on my number line, I will have a shaded circle at A, and my arrow would point towards the right. Now, for case 7, the set of real numbers that are less than B. Less than B means, in set builder notation, X such that X is less than B. And on my number line, I'm going to have an unshaded circle at B, and the arrow would point towards the left. For the last case, the set of real numbers which are less than or equal to B. Can you try to think how you're going to write it in set builder notation? Yes, this is how we write it. X such that X is less than or equal to B. And on a number line, do you still remember how we can represent it? Yes, we are going to have a shaded circle at B, and my arrow would point towards the left. We now move on to one example. Write down the inequality represented on each of the following number lines using set builder notation. So the first part, how are you going to represent this in set builder notation? So here it is X such that X is less than 4. Part B. Here I have a shaded circle at 2 and my arrow is pointing towards the left. So how will you write it? X such that X is less than or equal to 2. Part C. I have two unshaded circles at -3 and 3. So in set builder notation, it's going to be X such that X lies between -3 and 3. The next part. Here you have a shaded circle at -2 and an unshaded circle at 4. Can you try to write this inequality in set builder notation? Yes, here is the answer. I'm sure you must have written it correctly. X such that X lies between -2 and 4, but including -2. Now we move on to intersection of two sets of real numbers involving inequalities. Do you still remember that we have come across the terms intersection and union in the previous grades in the chapter sets? Do you still remember what is meant by intersection? Yes, intersection means the elements which are common to both sets. If suppose I have set A and set B, A intersection B would mean the elements which are common to both sets A and B. So let us consider this. The set P here is x such that x is less than or equal to 3, and Q, for the set Q, x is such that x is greater than or equal to -1, where x is a real number. We are now going to represent the sets P and Q on a number line. So I'm going to have a full circle at 3 with my arrow pointing to the left for the set P. For the set Q, I'm going to have a full circle at -1 with my arrow pointing to the right. Now, I need to find the intersection of these two sets. That is, I need to find the elements which are common to both set P and set Q. Can you try to see on the number line what are the values which are going to overlap for set P and set Q? Yes, the shaded region, the red region, represents the set P intersection Q. So these are the values which overlap for both sets. So this is the part showing P intersection Q. How are you going to write it in set notation? So you can see that here I have a shaded circle at -1 and a shaded circle at 3. So in set notation, this is how you're going to write it. Shaded circle, remember, means that x can be equal to this value. So this is P intersection Q. Now let us look at this example. The sets A and B are defined as follows. A equal to x such that x is less than 2, and B equal to x such that x is greater than or equal to -3, where x is a real number. Part A, represent on the same number line the sets A, B, and A intersection B. Part B, express A intersection B in set builder notation. So let us have a look at the solution. I need to represent the set A and the set B on the same number line. I'm sure by now you know how to do this. So I have an unshaded circle at 2, and my arrow would point to the left for the set A. Now for set B, I will have a shaded circle at -3, and my arrow would point towards the right. This is for set B. Now, what about the intersection of A and B? Can you try to find where A and B intersect on this number line? Yes, the red region represents A intersection B. But I need to be careful. You can see that for the set B, the values would start at -3, including -3, and I move to the right. Okay? For the set A, I start at 2, but 2 is not included, and I move to the left. So for A intersection B, I would have a shaded circle at -3 and an unshaded circle at 2. This would represent A intersection B. And in set builder notation, this is how I'm going to write it. Now, union. What does union mean? Suppose I have two sets, A and B. What would be A union B? A union B would be all the elements found in set A and also the elements found in set B. We take all the elements found in set A and all the elements found in set B. So let us look at this. Consider the sets R and S. So I have my set R, X such that X lies between -4 and 3. 3 is included, and S, X lies between -2 and 5, and here -2 is included. Remember, X is a real number. So on my number line, I will have the set R and the set S. Now I need to find R union S. So I need to find all the elements which are found in set R and the set S. So here is R union S. And in set notation, I'm going to write it as R union S equal to X, such that X lies between -4 and 5. So you should take all the values found in set R and all the values found in set S. Let us look at this example. The sets C and D are defined as follows. So you have your set C and you have your set D. Part A, represent on the same number line the sets C, D, and C union D. Part B, express C union D in set builder notation. So here is the solution. The set C, X lies between -3 and 4. Both -3 and 4 are included. So here is the set C on the number line. Now for the set D, to find the union of C and D, I need to find C union D. So I need to be careful here. C can take values from -3 to 4, including -3 and 4. D can take values from -4 to 3, but here 3 is not included. -4 is included. So what will be the union? You can see here, but I'm going to include -4 and 4 for the union, C union D. In set builder notation, this is how we are going to write it. Now, here are a few exercises for you to practice on intersection and union and on the set builder notation. So the first two questions are on intersection, and the next two questions are on union. You also have two links on the set builder notation. I would advise you to go and visit these two links so that you get some additional practice on how to write the set builder notation. So friends, we have reached the end of today's video. And in this video, we have learned how to use the set builder notation in inequalities. And we have also learned how to write the union and intersection of two sets of real numbers involving inequalities. We have reached the end of the chapter Inequalities. This is the last part on the chapter. So I hope you have understood the concept inequalities. So it's goodbye from me.